Welcome back, and today we're going to talk about changing concentration, surface area, or agitation, and how these can affect the rate of reaction. We'll also look at what we mean when we talk about concentration and surface area. So let's get started. When we talk about the concentration of reactants, we're talking about how much reactant is dissolved into the solution. So if we think about this, we can think about the analogy of an airport. If we were walking through an airport that had only 5 other people in the terminal, then there wouldn't be many chances to bump into someone. We'd be able to move freely. Then we probably wouldn't collide or bump into anyone at all. But if we make it different and perhaps are traveling through an airport at a crowded Christmas time or during the school holidays, then what we would find is that the terminal is full of people. It's going to look more like this picture down in the bottom right-hand corner down here, where we're going to see that our terminal is full of people. And then it becomes harder to avoid collisions, especially if people are rushing about. Okay, so same can be said for reactants when they're in solution or dissolved in. When we have a concentrated solution, okay, what we're saying is that there is a large amount of particles in a given area, like a crowded airport. If we have a dilute solution, then it means that we have very few particles. We have few particles in solution. Okay, so there's not actually much going on. There's large spaces between the particles. So that means that there's going to be essentially less chance for them to collide. So when we talk about how many particles are in a given volume, chemists use the term concentration. You may have heard of this when you've made up cordial, and the mix that we use to make up cordial is known as the cordial concentrate or fruit juice concentrate. This is because that's a concentrated solution of the flavoring and the sugar, and then we dilute it down to our preferred taste level. And when we're diluting it, what we're doing is adding in more water per the amount of concentrate. So the more reactants that we have dissolved, the higher the concentration that we have. Okay, so the fewer reactants dissolved, the more dilute the concentration. So what this means is that the more reactants there is, we increase the chance for collisions. So if we have more reactants bumping around in solution, we're going to see more collisions because there are less spaces between particles. And of course, if we have more collisions, then we're going to have greater chance of successful collisions when we want our reactant to occur, because our reactants are going to have a greater chance of bumping into each other, which flows on to our ideas of collision theory. So if we have few molecules and there are few collisions and the reaction is low, because remember, according to collision theory, we must first have a collision, and that collision must meet 2 criteria. That is that the energy of the collision is greater than the activation energy, and that it occurs with the correct orientation. Has the correct orientation. So if we simply increase the number of collisions, we increase the chance of there being a successful collision in a given period of time. So when we increase the concentration, we now have much less space between these particles. It's more likely the reactants will collide, and therefore we will see an increased rate of reaction. Okay, so when we increase the concentration of the reactants in a chemical reaction, we see a corresponding increase in rate because we have more reactant molecules present. They're more likely to collide, so we are more likely to see a successful collision. So that's how we talk about concentration in terms of changing the rate of reaction. The next one that we're going to talk about is agitation. This one is one that we don't talk about much beyond year 10, because generally chemists will always stir their reactions. So it's not a matter of there being stirring or no stirring. Reactions usually in a laboratory setting will always be stirred to ensure that it's being mixed thoroughly. So we know that stirring makes something dissolve faster. If you've thought about stirring your sugar into coffee or tea or Milo into milk, it's going to mix through the milk much more easily if we stir it. So without stirring, the reactants just sort of sit there and we're waiting for convection to sort of mix them up and things like that. So without stirring, the reactants can become separated, so the reactant may settle down to the bottom, which means it's not mixing in amongst the other reactants. So this will reduce the number of collisions because you're only going to have collisions occurring at this top surface here. Okay, the other thing that can happen is that the products can build up around the reactants. So as the reaction occurs here, we're going to get a buildup of products. And this means now that we're going to slow the reaction rate because the two reactants can't come into contact with each other. If we stir the reaction, like we're seeing up here with a magnetic stirrer, okay, then that means that we can constantly be moving the solution so that they're all mixing and tumbling in amongst each other. So we don't get this settling and the reactants are constantly moving around each other, which means we're going to increase the chance of collisions and we're going to see a faster reaction rate because we will have a greater chance for successful collisions to occur. So that's stirring. It's a pretty easy one. It's just making sure that the reactants are able to constantly come into contact with each other, increasing the number of collisions. The last one we're going to look at in this video is surface area. So you may have studied surface area in maths where you've had to work out the surface area of a solid. And what this means is that if we have a single cube, if you think like a sugar cube, then we have just the surface of that cube, if you think about being in three-dimensional space, is able to collide and react with the reactants in solution. So everything in here on the inside is unable to react. So if we grind up that cube into many smaller cubes, like we see with sugar crystals, in granulated sugar that you might use to put in your tea and coffee, then what we see is we increase the surface area because now all these extra surfaces are exposed. So before we would have just had this surface exposed here. Now we have all these extra surfaces exposed, so we have more reactant available to collide with the other reactant particles in solution, which means we're going to increase the number of collisions between reactant particles, increasing the chance of a successful collision, therefore making our rate go faster. Okay, so the reactions will occur faster if the solid reactants are ground up rather than in one solid block, because the liquid reactant or the solution can react with more of the solid material as the surface area is increased. The liquid reactant is able to access more solid material. There's a greater number of collisions. More collisions means a greater chance of successful collisions, and we see an increased rate. So that's basically how we go about explaining the increased rate of reaction for an increase in concentration, for an increase in agitation or stirring, and for an increase in surface area. All of these come back to being able to explain how they increase the number of collisions and therefore increase the chance of a successful collision occurring. Of course, our successful collision being one that has the right amount of energy and the correct orientation. And I'll see you in class.